Today we are going to learn how to do interpolation in steam tables. We need the values of specific volume, specific enthalpy and specific entropy of steam during the calculation of steam power cycle problems and other problems which include the requirement of steam. These values are given in steam tables in two ways. One is based on temperature and the another is based on pressure. The values for superheated steam are provided separately in final chapters corresponding to both pressure and temperature. If we need any value corresponding to either temperature or pressure, which falls in the interval, we should use the interpolation method to find it out. This is the interpolation formula y minus y1 by y2 minus y1, which is equal to x minus x1 divided by x2 minus x1. To know what these x, x1, x2, y, y1, y2 are, let us suppose an example. Suppose we need to find a specific entropy of dry steam at 32.45 degrees Celsius. Okay, what we have to find is specific entropy against the given temperature 32.45 degrees Celsius. That means the unknown value is specific entropy and the known value is temperature. Unknown value is taken as y and the known value is taken as x. Okay. Temperature 32.45 degrees Celsius falls in between 32 degrees Celsius and 33 degrees Celsius. In steam tables, only values corresponding to 32 degrees Celsius and 33 degrees Celsius are given. Therefore, we have to find the value corresponding to 32.45 degrees Celsius using interpolation method only. Hence, x1 is 32 degrees Celsius and x2 is 33 degrees Celsius. That means x1 is the lowest value and x2 is the highest value. The value we need to find is falling in between these two values, which is taken as x. Okay. Now we get clear what x, x1 and x2 are. Okay, in this interpolation formula, now we have x, x1, x2 and also y. What these y1 and y2 are? The specific entropy corresponding to these two temperatures. That means the known temperatures, they are given in the steam tables, 32 degrees Celsius and 33 degrees Celsius are these S1 and S2, these values. Okay, these values are the y1 and y2 corresponding to x1 and x2. Okay, now we have everything x, y, x1, y1, x2 and y2. We have to just substitute everything in the formula and we have to find out the unknown value, that is the y, that is the specific entropy. These x, x1 and x2 belong to known variable terms. That means some value will be given and we have to find out some unknown against those knowns. Okay, that means x, x1 and x2 belong to known variable terms and y, y1, y2 belong to unknown variable terms. Okay. Let's see some examples to get a clear picture on how to do interpolation. This is the first example. Calculate the specific enthalpy of superheated steam at 26 bar and 500 degrees Celsius. Okay, in steam tables, both pressure 26 bar and temperature 500 degrees Celsius are readily available in the superheated steam tables. So, interpolation is not required in this case. Okay, corresponding to 26 bar and 500 degrees Celsius, the specific enthalpy given in the steam tables is 3460.6 kilojoules per kg. Okay, now we are going to example 2. Calculate the specific enthalpy of steam at 150 bar and 520 degrees Celsius. In steam tables, the pressure 150 bar is readily available in superheated steam tables, but temperature 520 degrees Celsius is not available. So we have to interpolate values corresponding to the lower temperature 500 degrees Celsius and the higher temperature 600 degrees Celsius, because our temperature 520 degrees Celsius is falling in between 500 degrees Celsius and 600 degrees Celsius. The temperature terms T, T1, T2 are known variable terms. Therefore, x is equal to 520, x1 is equal to 500 and x2 is equal to 600. x1 and x2 are the lower and higher terms respectively. The specific enthalpy terms, that is what we are going to find out, that h, h1, h2 are unknown variables. Okay, h1 and h2 are provided in steam tables itself corresponding to the temperatures T1 and T2 respectively. I have to note it down. Therefore, y is the value that we are going to find and y1 and y2 are known values. Okay. Now we have x, x1, x2. Similarly, y, that is we are going to find out, and we know y1 and y2. Substitute all these values in the interpolation formula and we will get the y, that is the specific enthalpy. The calculation goes like this. and finally we get the specific enthalpy. Okay, let's take another example too. Calculate specific entropy at 24.6 bar and 500 degrees Celsius. Temperature 500 degrees Celsius is readily available in the steam tables in the superheated steam tables section, but pressure 24.6 bar is not available. In the last example, the temperature falls in the interval, but the pressure is readily available in the steam tables. But in this case, the temperature is readily available in the steam tables, but the pressure is not available in the steam tables, which is falling in the interval. So we have to interpolate the values corresponding to the lower pressure 24 bar and the higher pressure 26 bar. Okay, now the pressure terms are known variables. Hence we have the x, x1 and x2. Okay, the specific entropy terms S, S1, S2 are unknown variables. From superheated steam tables corresponding to the 500 degrees Celsius, we can take the specific entropy terms corresponding to pressure, lower pressure 24 bar and the higher pressure 26 bar. Okay, now we have Y1 and Y2 too. What we have to find is Y. Okay, let's substitute all these values in the interpolation formula, and the calculation goes like this. Finally, we get the unknown specific entropy as 7.3323 kilojoules per kg Kelvin. Now we are going to see an important example. Many students have more confusions in problems similar to this example only. Okay, calculate the specific enthalpy at P equal to 2.3 bar and temperature T is equal to 450 degrees Celsius. Both pressure and temperature, the 2.3 bar and 450 degrees Celsius, are not readily available in the steam tables. So interpolation has to be done for both pressure and for temperature. Okay, this interpolation has two steps. In the first step, we have to calculate the specific enthalpy corresponding to pressure 2 bar and temperature 450 degrees Celsius, and also for 2.5 bar and 450 degrees Celsius. What we are actually doing is we are going to interpolate the values corresponding to temperature in the first step, and in the second step we will do the interpolation for pressure also. We are first going to calculate the specific enthalpy value corresponding to 2 bar and 450 degrees Celsius, and similarly 2.5 bar and 450 degrees Celsius in the first step. And after that we are keeping the 450 degrees Celsius, the temperature, as a constant one, and the variable terms are 2 bar and 2.5 bar. What we are going to find out is the specific enthalpy corresponding to 2.3 bar. So we have to interpolate in the second step for pressure corresponding to pressure only. Okay, now let's take the values from steam tables. The values corresponding to 2 bar and 400 degrees Celsius and 2 bar and 500 degrees Celsius, that they are the H1 and H2. These values are given here. The known things are temperature, therefore they are taken as X terms, and the unknown thing is enthalpy, specific enthalpy, which are taken in the Y terms. Okay, now substituting in the formula, we get the specific enthalpy corresponding to 2 bar. Similarly, if we take the values corresponding to 2.5 bar and the temperatures 400 degrees Celsius and 500 degrees Celsius, we can calculate the specific enthalpy corresponding to 2.5 bar as 3381.2 kilojoules per kg. Okay, now what we have is the specific enthalpies corresponding to 2 bar and 2.5 bar, both corresponding to 450 degrees Celsius. Okay, in the second step of interpolation, we have to do the interpolation for pressure. Okay, now the known variables are pressure terms. In the first step, the known variable terms are temperature terms. Okay, now the x, x1, x2 are corresponding to pressure, and the y terms are as usual corresponding to specific enthalpy terms. Okay, now substituting in the formula, we get the final answer H is equal to 3381.46 kilojoules per kg. I hope you got a clear idea. Now let's try this example as a tutorial. I will guide you. Find the specific enthalpy of dry steam at 112.44 bar. In this case, the pressure terms are the known variable terms and the specific enthalpy are the unknown variable terms. Okay, get the values from the steam tables and substitute in the formula, and you will get the final answer. Okay, similarly, you have another example too. Calculate pressure of steam at 360 degrees Celsius having specific entropy 7.0844 kilojoules per kg Kelvin. So far we have seen so many examples. in which pressure and temperature terms will be given. What we have to find out is specific entropy or specific enthalpy. Okay, but in this case, the specific entropy is given. What we have to find out is pressure. As usual, we can do the same interpolation method. The given temperature falls between the temperatures 350 degrees Celsius and 450 degrees Celsius. That means the lower temperature is 350 degrees Celsius and the higher temperature is 400 degrees Celsius. And the specific entropy value given falls in between 16 bar and 17 bar. You can find it out in stream tables. Okay, therefore we are going to do interpolation in two steps. First, we have to find out the specific entropy value corresponding to 16 bar and 360 degrees Celsius. And also, we have to calculate the specific entropy corresponding to 17 bar and 360 degrees Celsius. Okay, this is the first step. And using these two specific entropy values, we are going to calculate the pressure as like this. In this step, we are going to calculate the pressure corresponding to the given specific entropy. I hope you got a clear idea how to do interpolation in steam tables. Thank you for watching. Subscribe the channel to learn more. I will meet you with new videos as soon as possible.